This video is going to be about a project that Augustana College Environmental Studies 100 and Interlevel Environmental Studies class helped participate in, and it was analyzing the health of both an upstream and downstream location of a local stream, different metrics, and what it could possibly mean based on the environment. This video on the project is going to be talking about specifically the nutrient presence in the water and how it affects the stream health, the wildlife health, and what that means for us and what we should be doing about it. The two main types of nutrients we're going to be looking at are nitrogen and phosphorus, particularly in the form of nitrates or any sort of nitrogen-oxygen compound, and phosphates primarily, which is a phosphorus-oxygen compound. Both are used for the construction of DNA. However, nitrogen is found both in the atmosphere, but also in its most usable form when it comes from dead bodies or when it is converted by different types of bacteria. It's from an organic source, meanwhile, phosphorus is from inorganic sources. In nature, that should be rocks, but as you will see later, there are other forms of waste that can produce phosphates in the water. Further on the nitrogen cycling, most of it is stored in the atmosphere, but different types of bacteria convert it into useful forms that then get absorbed and assimilated by plants and animals, an important discussion point for later, who then break down and decompose back into more nitrogen for decomposers to fix it again, either release back into the cycle or re-release into the atmosphere. Normally, this balances itself, but in some cases, that is not the case, which can really disrupt the atmosphere or really disrupt the environment a lot. Similarly, in the natural course, the phosphorus cycle primarily goes through rocks, sedimentation, plate tectonic movements, soil erosion, uplifting, and then weathering, all back and forth. However, there's also things like agricultural activities, resource mining, and the one that we're going to be looking at specifically is pollutants and waste that can release a disproportionate amount of phosphorus where we don't really want it. Now in this data here, you can see that a significant increase in both nitrates and phosphates in the upstream, that is the blue sampling area, when compared to the orange downstream sampling area. On average, we were closing in on 4 milligrams per liter of nitrates, which is still within the acceptable range compared to the less than 3 in the downstream example. Then the upstream phosphates, we had close to 0.4 milligrams per liter and a little bit over 0.2 in the downstream example. Now, all of these values are in the range of what's considered healthy for a stream, so we're not actually too worried about that. What we are worried about is the fact that these two sampling spots aren't that far away, but there is a very stark contrast between the levels in each, meaning that something is really messing with the upstream sample that could be indicative of a larger issue. Now, the next reasonable place to look for what could be causing these differing nutrient levels is the environment surrounding the streams. In the upstream sample, it was surrounded by a busy road, a parking lot, a lot of litter, and a lot of stores who probably dispose of their waste in one way or another in the vicinity. This could be contributing a lot into both inorganic and organic waste, raising both the levels. And there's also the water runoff from concrete whenever it rains, or any of the plastic that gets left in the stream. When you compare this to the downstream sample, which is in the middle of a golf course, with the exception of the occasional fertilizer, there isn't much outside interference in what could be directly depositing into the stream. Now again, the nutrient levels themselves were not really problematic in their quantities or amounts, but whatever is causing them to be so changed in the upstream location is also having significant effects. Now, this metric here, catches per unit effort, is merely representing the amount of fish that were caught per test run with our fish sampling team, and we see that there's significantly less, almost half the amount, a little bit more than that, in the upstream location, with 81.6% more what we call productivity, or catches per unit of effort, in the downstream location. Basically, there is significantly higher abundances of fish in the downstream location. Conversely to that, while whatever is causing these changes has a negative effect on catches per unit effort, it has a positive effect on, or rather a positive correlation, it's not a positive effect, with the amount of delt or hybrid type fishes that are in the stream, with upstream having 134% increase, well over double the ratio compared to the downstream location. Now, what a DELT property actually is it's an acronym for a deformity, erosion, lesion, or tumor. It's basically any sort of disease or mutation that could be messing with the fish, making it sick, or rendering it unhealthy, or some larger issue. These are some examples of some type of DELT properties you'd see. Small graphic warning, these do look slightly gross. Now, DELT properties do exist on a spectrum, with some discoloration and bloating of the skin here to a fish quite literally having two mouths. There exists a wide variety of spectrums of DELT properties, but they're almost always indicative of some larger issue or sickness or problem with their environment or their own genetics. Now, going back to our observation of the surrounding environment in both locations, we noted that there was a much higher plastic level as well as concrete. Concrete and plastic can both contribute to phosphorus levels, and the reason that could possibly be a problem is because if plastics are breaking down and releasing phosphorus, that's not the only thing that they are releasing. They can release a lot more harmful types of compounds that could be carcinogenic or in other ways causing sickness or some sort of disturbance in the local environment. Given that carcinogens, cancer-causing chemicals, are responsible for causing tumors, a type of DELT formation, it is a reasonable leap in logic to see a increase in plastic coincide with an increase in tumors or sickness in the water. Okay, so fish are dying and they're getting sick, and it's maybe plastic's fault. Who cares, right? Well, the thing with these streams is that they all collect in a reservoir, which can be used by locals for provisioning different types of services. The easiest one to name would be provisioning water directly from it. Now, this isn't as much of a problem with smaller reservoirs, as the majority of the people in the area of this experiment get most of their water from the Great Lakes. However, there is still issues with provisioning any sort of kind of service from this, as well as regulating services, which are essentially the ways that the stream and water kind of keep the environment alive. In addition to how these chemicals and compounds can mess with fauna life, that is animals, different types of macroinverts, and fish, it's also possible that it messes with different types of floral life, that is plant growth. Something that we saw significantly less of in the upstream sampling location is that there was significantly less both different types of flora and fauna. There was much less diverse and much more sparse for both. Now, this could also be because the assimilation rates, if you remember up here, you have assimilation into plants. Plants that assimilate in waters that are too toxic or have harmful chemicals in them die off and leave only the hardier types of plants, which is not great for the biodiversity of the area. This could lead to more plants dying off or not thriving as much, which would in turn further decrease the amount of assimilation, which would further kill off the plants and cause a reinforcing feedback loop, which is basically where the effects of the loop fortify the cause and it builds upon itself over and over again. A very common example of this that we hear talked about in the environmental studies field is that of greenhouse gases and the ozone layer. For example, like you've probably heard about how as greenhouse gases increase, more heat is trapped by the earth, which leads to the melting of glaciers, which causes the oceans to absorb more heat, which causes more things to be burned, things like forest fires, which release even more greenhouse gases, which make the planet trap more heat. And you see how it continues on a not so virtuous cycle into a really bad downward spiral. In this instance, this leaves us with a dried up wasteland of a river with poor soil integrity from little plant life and no animal life, because everything is dead and there's too much of everything in the water and nothing can deal with that much. Now, it's sort of intuitive why total amount of plant and animal life might be a good comparison or a good metric for total stream health, but why do we actually care about biodiversity? Well, It's more of a trust the word of the experts on it. It's been widely agreed upon that biodiversity in acceptable ranges is better for an environment. It results in a more stable ecosystem with more factors out to balance each other. Because a balancing feedback loop is the opposite of the reinforcing feedback loop that we just talked about. So different types of species or taxa that counteract each other or keep each other in a balance is a good thing. Now, two different types of diversity metrics were used for this. There is IBI scores, which you can see the specific things that go into them here, like what it takes into consideration. Different types of diversity metrics weight different metrics more heavily than others, which is why even though the IBI score tells us that there is a difference between streams and a lot of things, I believe the total IBI is not listed here. No, it is. They're relatively the same here, and both within what's considered a healthy range for the bentho macroinvertebrates, which is essentially anything that lives in the stream that is not a fish. However, no, it's the same in the fish section too. However, these levels, like these total levels, the ones between 60 and 80 for the macroinvert level, are not at all matched by the fish levels. Now, what this probably means is that whatever is affecting the stream health disproportionately affects the fish levels, considering they are roughly half of what we have in the macroinvert scale. It remains to be seen why the IBI indexes of fish are affected disproportionately. However, there is another metric that we use for measuring diversity, and that is Shannon's diversity index. The Shannon diversity index levels that came in both sampling locations were both remarkably low, somewhere around the rounds of 1.7, 1.9, low to mid ones. And anything below a 2 is considered very low by the Shannon diversity index. So while the IBI seems to weight heavily the factors that the stream is supposedly doing well in, whatever the H values are weighting more heavily are simply things that are being underperformed by both locations. Now, that might be an entirely separate issue that we cannot measure the source of with the equipment and time that we had on hand. Both locations were noted as having a significantly higher proportion of intolerant species. This basically means that there are species that are much readier to can live in harsh conditions. Compared to normal streams, we want a roughly even balance between tolerant, intolerant, and moderate species, or different taxa. The lack of tolerant species and even the lack of intermediate species in comparison to intolerant species is what's giving this a low biodiversity, especially in Shannon's diversity index, as well as a much more direct sign of the negative health in the stream. Now, if a moral obligation to our environment wasn't enough, frankly, we live here. We use water, we use the river, we use ecosystems, environments for a lot of our needs, electronically, food, water, environmental regulation, dealing with heat, transport. We get so much from our environment, so taking care of the health in things like streams, and specifically using these smaller streams to figure out what we could be missing in rectifying the health of bigger bodies of water and larger rivers like the Colorado River or Mississippi, which is known for being filthy, could be beneficial for us for what we get out of them.